In this video, we're going to apply trigonometric substitution to prove that the area of a circle of radius r is pi r squared. We start with the equation of a circle centered at the origin, x squared plus y squared is equal to r squared. Let's solve for y squared. We will get y squared is r squared minus x squared. Square root both sides, we get y is equal to plus or minus root of r squared minus x squared. Now this is the, let's take the upper half of the circle, so y is equal to plus root of r squared minus x squared. And we can see that the full area of a circle is just 4 times the green shaded area, 4 times this region. So the full area will be, area is equal to 4 times integral from 0 to r, root of r squared minus x squared dx. We're going to prove that this area will be pi r squared. This is the goal of this video. Alright, so what we have is area is equal to 4 times integral 0 to r, root of r squared minus x squared dx. We'll look at the integrand, and we have r squared minus x squared. This is constant squared minus variable squared, because r is a constant. So we're going to apply the trigonometric transformation, x is equal to r sine theta. Differentiate dx is equal to r cos theta d theta. So we have root of r squared minus x squared. This is equal to root of r squared minus x is r sine theta all squared. Simplifying this, we're going to get root of r squared times 1 minus sine squared theta. Now r squared is root of r squared is r. We can pull it outside the radical and we get r root of 1 minus sine squared theta. This part is just cosine squared theta. That's a trig identity. Cos squared theta plus sine squared theta is 1. So we get r root of cos squared theta. That gives us r absolute value of cos theta, because root of cos squared theta is absolute value of cos theta. But because of the way we restrict the angle theta, theta is between minus pi over 2 and pi over 2, we can drop the absolute value. So we can write this as r times cosine theta. Alright, we now need to change the limits. We have sine theta is equal to x over r. And solving for theta by taking inverse sine of both sides, we get theta is equal to sine minus 1 arc sine of x over r. Now, if we put the lower limit, x equals 0, into theta is equal to sine minus 1 of x over r, we will get theta is equal to sine minus 1 of 0. What is sine minus 1 of 0? Well, that's just 0. Now let's put the upper limit, x equals r, that's theta is equal to sine minus 1 of x over r. We're going to substitute x equals r into this expression, and we will get theta is equal to sine minus 1 of r over r, which is 1. What is sine minus 1 of 1? What is arc sine of 1? That means, what is the angle whose sine is 1? Well, that's just pi over 2, because sine of pi over 2 is 1. So what we have shown is 4 times integral from 0 to r, root of r squared minus x squared dx. We have applied trig transformation to this integral, and we have produced a trig integral. 4 times integral from 0 to pi over 2, r cos theta times r cos theta d theta. Hopefully this trig integral will be easily solvable. So r cos theta, this part is just the integrand, root of r squared minus x squared. And this part, r cos theta d theta, this is just dx. Alright, so what we have shown is that 4 times integral from 0 to r, root of r squared minus x squared dx is 4 times integral from 0 to pi over 2 r cos theta times r cos theta d theta. So we have a trig integral, and we're going to solve it. R times r is r squared. It's a constant. It can pass right through the integral, so we get 4r squared integral from 0 to pi over 2 cos theta times cos theta. That's just going to give us cos squared theta d theta. Now we have a trig identity. Cos squared theta is 1/2 times 1 plus cos 2 theta. So we have 4r squared integral from 0 to pi over 2 1/2 times 1 plus cos 2 theta d theta. 1/2 is a constant, passes right through the integral. We get 2r squared. Integral from 0 to pi over 2. 1 plus cos 2 theta d theta. That's equal to 2r squared. Now let's integrate term by term. What is the integral of 1? Well, that's just theta. What's the integral of cosine 2 theta? We will apply U substitution. We'll let U equals 2 theta. Du is equal to 2d theta. Because it's easy, we just do it in our head. Integral of cos 2 theta will be sine 2 theta divided by 2. Integrated from 0 to pi over 2. Now we're going to apply the fundamental theorem of calculus and put the upper and lower limit in and evaluate this integral. So we get 2r squared times, putting the upper limit in, we get pi over 2 plus sine of 2 times pi over 2, and that's 2 times pi over 2 divided by 2 minus, now putting 0 in, we get 0 plus sine 0 divided by 2. Alright, now the 2 cancels with the 2, we get sine of pi. Sine of pi is just 0. And sine of 0 is also 0. Sine of any multiple of pi is 0. So when we simplify this, we get 2r squared times pi over 2. The 2 cancels out, and we get a result that we're after, pi r squared. The area of a circle of radius r is pi r squared. So now let's talk about some of the identities that we applied here. We applied sine squared theta plus cos squared theta is equal to 1. We also applied the half angle identity. Cos squared theta is 1/2 times 1 plus cos 2 theta. And we also did a U substitution, integral cosine 2 theta d theta, by letting u be equal to 2 theta. Du is the derivative, that's du is 2 d theta. And solving for d theta, that's going to give us du over 2. All right, thank you.